In this video, we're going to go through a set of example questions dealing with how to find arcs and angles when given central angles. For this first problem, we are given that arc PQ has a measure of 90 degrees. Find the length of PQ. So we're looking for this length here. So remember, when you have central angles, like this angle here, the angle is equal to the arc. So therefore, if arc PQ is equal to 90, then that makes this a right triangle. Now, because we know that all radii are congruent to each other, if PR is equal to 7, then RQ must also be equal to 7. Now from here, you can choose which way to solve. You can recognize this as a 45, 45, 90 triangle and know that PQ has to be equal to side times radical 2, or 7 radical 2. Or the second option you can do is just strictly Pythagorean theorem. So you could say a squared plus b squared is equal to c squared. 7 squared plus 7 squared is equal to c squared. 98 is equal to c squared. Square root both sides. C is equal to the square root of 98, which simplifies to c is equal to 7 radical 2. Therefore, we can state that the length of PQ is equal to 7 radical 2. In these next two problems, we're going to be focusing on what these congruent markings mean. Here, this marking on arc AC and BC means that those two arcs are congruent to each other, meaning they have the same degree measure. Because we know this is a central angle here, angle ADB is a central angle, and all of our other angles are central angles as well. But if this is 90 degrees, then I know that arc AB must also be equal to 90 degrees, since in central angles, the angle equals the arc. Now I'm going to apply and give arc AC and arc BC a value of x. I know that these arcs have to be congruent and equal to each other, so they are equal to the same value. Now, since a circle has 360 degrees, I can set up the equation 360 is equal to 90 plus x plus x. I can simplify to say 360 is equal to 90 plus 2x. Subtract the 90 from both sides to get 270 is equal to 2x. So x is equal to 135 degrees. So that means that the measure, now going back here, making sure we're solving the right thing, we want to find AC. And since here AC is indeed equal to x, we get that the measure of arc AC is equal to 135 degrees. Let's take a look at number 9. For number 9, we are given that all three arcs that are split up, the circle is split up into, are congruent to each other. So if I was to call each of these x, I know that 360 is equal to x plus x plus x, because there are 360 degrees in a full circle. So from here, I can say that 360 is equal to 3x, divide both sides by 3, so I get that each arc or x value is equal to 120 degrees. Now for this one, I'm going to go back to my question, and it says that I want to find the measure of arc ACB. Order matters here, so follow the letters as you go around. So the measure of arc ACB is equal to x plus x. So that's equal to 120 plus 120. So I get 240 degrees as my final answer for that. My next two problems are going to use a circle that I have to draw here. It says that there are two diameters of circle T. So I'm going to start off by drawing circle T. So my center point is T. and I have two diameters. I have PQ gets drawn in, and then my second diameter of RS gets drawn in. Now, of course, none of these are drawn to scale. It says that the given arc of the is going to be PR, arc PR, is equal to 35 degrees. So if I look here, I can write my given here that PR is equal to 35 degrees. Now, just because I'm remembering this is as part of a central angle, so the arc is equal to the angle, which also makes this a 35-degree angle. So the first piece of information we want to find here is the measure of arc PS. So it's going to be this arc right here. So for this one, I can see that this is part of a semicircle formed by the diameter RS. So I can take 180 degrees, I can subtract 35 degrees from it, which is arc PR, and the piece I'm left with is arc PS. So that's equal to 145 degrees. The second question wants me to find the measure of arc PSR. Now, order matters here, so follow those letters right around the circle. This is a major arc, so the way that I deal with major arcs is I take 360 degrees and I subtract my minor arc, which in this case is 35 degrees. So I say 360 minus 35 gives me 325 degrees for the measure of arc PSR. For each of these next set of word problems, I'm going to start by drawing my circle first. So it says, given circle O, with the points A, B, and C. A, B, and C. Those are each of our points drawn in. All of our radii are drawn in here. They line the circle. We are given that arc AB is equal to 155 degrees. And we're given that arc BC is equal to 120 degrees. And we want to find two pieces of information here. The first is the measure of angle BOC. So that's going to be this angle that we're looking for. And the next is going to be the measure of angle AOC, which is going to be this one here. So if I take a look first at my red angle that I want to find, BOC, I know for part A that when I'm dealing with central angles, the angle is equal to the arc. That's the only piece of information I need to know here. So therefore, since I know my arc is equal to 120, my angle must also equal 120 degrees. So the measure of angle BOC is equal to 120 degrees. For part B of this problem, I know that I'm looking for my major arc the angle AOC. So when I'm going to do this problem, I need to figure out what arc AC is equal to. So the way I can figure out what this arc here is equal to is by subtracting out what I have over here, this 155 and 120, from the total of 360. So I can state here, if I was to take 360 and I was to subtract out 155 and 120, that's going to be 360 minus 275 is equal to 85 degrees. So that means that this arc is equal to 85 degrees and this angle is also equal to 85 degrees. So the measure of angle AOC is equal to 85 degrees. In my next problem, I start again drawing my picture. So I draw a circle A, and I have a diameter drawn in here, BAC. And point D lies on the circle. So I can put point D anywhere. I'll just choose to put point D here. It says if the measure of angle BAD, so I'll draw that second radii in there, is equal to 123 degrees. It wants us to find the measure of arc DC. So what I'm looking for is this arc right here. So angle is equal to the arc. So I know if this is a 123 degree angle, then arc BD is also equal to 123 degrees. I know this is a semicircle, so I can say that the measure of arc DC is equal to 180 minus 123, which is equal to 57 degrees. In our next problem, we're given circle P. And we have three radii that are drawn, where we have radii PQ, we have PR, and we have PS. They're drawn such that the angle QPR is congruent to angle RPS. So we know that these two angles are equal to each other. We're also given that angle RPS is equal to 55 degrees. Therefore, this angle also has to be equal to 55 degrees. And as the last piece of information, we're given that minor arc QS. So QS, we'll switch colors here. QS is equal to 5x minus 25. So if we were to add up 55 plus 55, that gives us our full arc here. And because we know our angles are equal to our arc, I'm able to set up the equation 5x minus 25 is equal to 2 times 55. You can go ahead and solve for x now. 5x is equal to 135, so x is equal to 27 degrees. And that would be the value of x given our problem. In our next problem, we get a little bit more complex with our picture. So here we are told that we have, we want to find the measure of arc WV if we're given that angle VRU is congruent to TRU. So right away, we're given that these two angles are congruent to each other and as marked. So the first thing we have to do here is we're going to start to, so our goal, remember, is to find this value of arc WV. So looking at this problem, the first thing that we want to be able to see is kind of break through some of all these lines that are here and really just focus on our two diameters that are drawn. Diameter WRT and diameter VRS. So when I isolate those pictures, what I end up seeing are a pair of vertical angles. So what I can do is set up the equation that 12x minus 2 is equal to 2 times 5x plus 10. Because I know if these two given angles are congruent to each other because they're vertical, then their arcs must also be congruent to each other because in central angles, the angle equals the arc. So I can go through and solve this. So I get 12x minus 2 is equal to 10x plus 20. Subtract my 10x to get 2x minus 2 is equal to 20. 2x is equal to 22. So x is equal to 11. From here, I can substitute that value of 11 into my values of my equations here, or my expressions. So I can start off by saying 5 times 11 plus 10, and that's going to give me 55 plus 10 is equal to 65 degrees. So I know that this angle and arc are going to be 65 degrees. 65 degrees because it was given to us that they were congruent. From here, I know that I can take, to find my measure of arc VW, I can use this diameter that forms this complete semicircle. So I can say that the measure of arc WV is equal to my semicircle of 180 and subtracting out my two angles that are 65 degrees. So from here I get 180 minus 130, which is equal to 50 degrees. So the measure of arc WV is equal to 50 degrees. Really quick, we're going to take the look at one last concept, and that's going to be that arcs are congruent if the circles have the same central angles and the same length of radius. So both of these conditions have to be met in order for arcs to be congruent to one another. So if I take a look at my first example here, we have that our angles are both congruent to each other. This angle here, arc JK and arc QR, are both equal to 105 degrees. However, because this radius is 4 and the radius in our second circle is equal to 4.5, I know therefore that these two arcs are not congruent because the radii from each of these circles are not equal to each other. And the last one here in our set of problems is going to be number 17. So if we look here, we're going to be comparing arcs AB and arc CD. So here, if we look at this, we have an angle that's going from a diameter here. So we have 42 degrees and 96 degrees, which makes this last angle 42 degrees. So we add up to 180. So they are both equal to 42 degrees. And since they are part of the same circle, we know that all radii of a circle are congruent to each other, or all equal to each other. So therefore, because in this specific picture, we have that our radii are equal, and we also have that our angles are equal. They were both equal to 42 in this case. I can therefore state that the arcs AB and arc CD are congruent because the radii and angles are the same. And that completes our problem set dealing with finding the radius and angles of central angles.